What is the last thing that you have done? No, not ionic, not ionic. Ionic will be combined. So I'm asking about organic. So in organic, this we have done. Just please confirm. Okay. Have you done plus M minus M, mesomeric effect, resonance effect? Not yet. Check this. Niharika, Chinmay, Arjun, please turn on your cameras.
Sir, is this B1 batch organic?
Yeah, we are just completing. You have done this part, Arjun?
Yes, sir. Sir, I finished all this because, right?
Okay. Okay. So I think one lecture still pending, one or two lectures, and then
Okay,
Ionic
sir.
anyway, you please attend. Ionic don't
Yes,
miss.
sir. Sir, I'll join Ionic, but then right now,
Sure.
can I leave? I have to finish
Yeah,
lab
sure,
test
sure,
because.
sure. It's
Okay,
okay.
thank you.
Okay. Please settle down fast. Akshay, Shyam. So please confirm, have you done this part? Inductive effect you have done? Asha, this question we have done. I remember this question. We have done. Right. This also we have done. Mesomeric we have done or not? No? Pakka? Akshay ji, what is the last thing you have written in notebook? Inductive. Okay. Okay, fine. So write down the heading, mesomeric effect or resonance effect. यहाँ से शुरू कर लेते हैं. So let me just tell you how much time will require. Almost 22 pages left. So this will take, probably today we will be able to complete because ज़्यादा कुछ है नहीं. हो जाएगा. Hopefully. Let's see. Let's try. ठीक है. नहीं हुआ तो आपको ब्रेक उड़ा देंगे. And then, don't worry. चलो. शुरू करें? Please pay attention. इधर ऐसे घूम जाए. Because if you write like this, you will create problem for your back. Okay. So you sit straight, write like this. If you want to twist and write, you can go back and write. ठीक है. So, can we keep these bags aside? Looking very cluttered. Just pass it backside. ये किसका है? ये आपका है? Keep it with you. तो ज्यादा clutter होता तो फिर then I'll. रुपेश जी, ये प्लीज आप ले लीजिए. पास कर दीजिए. All right, let's start. Mesomeric effect or resonance effect. Write down the heading. Mesomeric effect or resonance effect. What are different type of resonance that we know? Plus single double, negative single double, lone pair single double, radical single double, plus single lone pair and double single double. Clear? ये पता है सभी को? Chinmay and Niharika.
Yes, sir.
Can you hear me? Can you please turn on your cameras? Both of you. Yes. Any difficulty in this? Any difficulty in this? So these 6 types, all of you know. ये पता है आपको? Multiple times you have done these things, right? So let's not go into that. Now coming to the next part. When you talk about this effect, this particular effect, what is meaning of it? Let's understand that first. Rupesh ji, where's pen? Pen. No, pen for this. अंदर चेक करो, सर से पूछो. उसमें तो नहीं दिया, मैंने सामान जो आपको दिया उसमें चला गया। हाँ, नीचे गिरा। थैंक यू सो मच। So right now, under mesomeric and resonance effect, so they are almost equal, but not exactly equal. That's the first point you should know. When I say mesomeric effect or resonance effect, they are not exactly same. There is some small difference, but as of now, at a very early stage, we can say both are same. Okay, let's not go into detail of why they are slightly different. So I'm just using this symbol, not exact equal symbol. They are almost same. Now mesomeric can be of two types, plus M and minus M. Resonance can be of two types, plus R and minus R. Okay. What is meaning of plus and what is meaning of minus? Plus means if you have lone pairs attached to a ring and it supports the ring, that's plus M. And if you have lone pair, sorry, if you don't have lone pair, let's say if you have some group which pulls electron away out of the ring, that's minus M. So first case, you are sending it inside. The other case is you are pulling it outside. First case comes in plus M. Second case is minus M. Who is plus M? This lone pair group is plus M group. And who is minus M in this? This group which is pulling electron is minus M. Is it clear? Niharika, Chenmai, is it okay? Any difficulty in this part? Any issues in this part? Very nice. Now, how will you recognize whether it is plus M or minus M? इसका बहुत simple criteria मैं देता हूँ. If you have a group which has a lone pair, it will mostly send inside the ring. I'll show you something. Let's say we have a ring like this, and I put OH, or a ring like this. Let's say put NH2, ring like this, SH. Please draw. Keep drawing. Be a little quicker in writing today so that we can close the portions also. थोड़ा सा स्पीड में लिखोगे तो हो जाएगा. What is common in all these examples? What is common in all these examples? In all these cases, you have ring or the cyclic structure connected with some group, some element which has lone pair. So please draw. Is it clear? Adya, turn on camera, please. Adya, Niharika, and Chinmay. Is it clear, everyone? Can you observe this common feature in all of them? They have all lone pairs, right? That's a common feature. Please. Now coming to the next part, what will happen because of this lone pair? So see, due to this lone pair, we have lone pair, single and double bond formation. And this formation will be acting in this way. So this lone pair will push electron. You can create a negative charge at this place, right? Option number 1. So how will the structure look like? So the structure may look like negative charge, double O, H, plus out of 2 lone pairs, 1 is gone. I'm putting 1 plus charge. 1 plus and 1 negative is neutral. This was neutral. This is also neutral. Confirm these things. Any problem in this? Is the structure clear? So when lone pair moves here, this becomes a double bond. This double becomes negative here. Fine. And we get negative, double and plus charge. Easy? Arav? Clear? What will be the next step? Next step you can say this goes here and this comes out here. Negative can reach here. Next time somebody can send this negative here. So can you draw the different resonating structures which we have practiced earlier also? Can you do that? Please note down. Adya, is it clear? Okay. Any difficulty in this? Any issues in this? So in all the cases, can we observe the same thing? NH2, sulfur, oxygen, NH, sulfur, oxygen. Check all the cases. Everywhere we are doing the same thing. Everywhere there is a common feature. The group has lone pair. Isn't it simple? So any group carrying lone pair is plus M for you. बिल्कुल सिंपल कर दिया मैंने आपको. ग्रुप देखिए lone pair है तो plus M मान लेना. Plus M के ऊपर क्या हो सकता है? That's a secondary discussion. But plus M is clear. Is it simple? The group is plus M. Now see other part. Other part is this group is other than plus M. It will pull electron from carbon. See, this is carbon. This is oxygen. O is more electronegative. It will pull with minus sign. Nitrogen, carbon. It will pull with minus sign. Sulfur, carbon. अब सल्फर कार्बन में सीक्वेंस देख लो. फ्लोरीन, ऑक्सीजन, नाइट्रोजन, क्लोरीन, ब्रोमीन, sulfur, carbon, iodine, hydrogen. This is a sequence. So sulfur is still above the carbon. Slightly pull. Oxygen, pull. Sulfur, slightly pull. Oxygen will pull. Nitrogen pulls. Nitrogen pulls. Oxygen pulls. Oxygen pulls. Again. So can you observe? Though they are supporting the ring, but they're pulling it away also. Pulling it towards them. I repeat. It's like giving back, taking it back. Giving and taking back. But the one which is giving is what? It is plus M. It is plus M. Positive mesomeric. And the one with which you are taking back is just minus I. अब होता क्या है? Plus M is much more bigger as compared to छोटा minus I, small minus I. So eventually they end up giving. Okay, you give someone 10 pencils, take 1 pencil back, eventually give 9 pencils. Simple. So plus M is a huge thing. Plus M is much more important because it's coming out of resonance. Okay, Rupesh, can you just turn this to my side? It will be easier. So plus M is perfect. Plus M is pushing inside and minus I is pulling it back. Easy. All these cases, feature is similar. I hope you understand this. Any problem, please ask. यहाँ तक कोई दिक्कत है तो पूछ लीजिए. Clear हो गया? Mesomeric effect is clear. Inductive effect is clear. So can you give me example of group which is having plus M and minus I? What will be your answer? If I ask you, give me example of groups which are having plus M and minus I. Akshay, what will be example? Can we say all OH, NH2, SHO, this, everybody is doing plus M minus I. But if I ask a question, Chinmay, give me a group which is plus M and plus I. अब क्या करोगे? Chinmay,
I'm not sure, sir.
Okay. Anyone who can answer this question? Plus M and plus I. Huh? Carbon ion. C negative. But C negative will push electron with plus M. That's a good thought. Iodine again. Iodine is anyways mild polar. So you have to find something which can push electron to carbon, right? That's how the thought is. Now write down this, and this is a very important question also. I'm highlighting it separately so that you don't forget this. Write down groups like O negative, groups like NH negative, okay? Groups like O negative, groups like NH negative. These kind of groups where you already put negative charge, they start pushing electron. Now you can say, sir, oxygen is electronegative. Why it is pulling electron? Why not it is pulling electron? Because it is O negative. So O is having not that much space where it will pull. It will start pushing electrons back. Fine. Because of this negative charge. So O negative will push electron back. NH negative will start pushing electrons back. It will pull. No. It will push with plus I. It will push with plus M also. So they are plus M and plus I group. Please make note of it. This is an important question. Everybody please make note of it. This is an important question. Clear हो गया? Niharika, is it clear? Chenmay? Adya? Any issues with this? Any problems with this part? Can we go further? Please note on the heading, write on the heading, minus M groups. Minus M groups, देखते हैं कि minus M groups क्या होते हैं? Minus M groups. Can I remove this discussion? Okay. Write down minus M group. Minus M is also called negative mesomeric effect. Negative mesomeric effect, which is observed when the group is available, which is pulling electrons, right? So it should pull electrons. Now, what kind of group will pull electron? Think electronegative, and there should be some kind of bonds which can take it from there. So let's see this example. What is special about it? Please observe. Oxygen is more electronegative than nitrogen. So this pulls here, and this pulls like. देखो बाहर जा रहा. Can it send inside? There is no lone pair. It can't send inside. Can you observe the type of group, variety of group? Okay, chale. So start observing. I'm drawing certain structures. Please observe and try to answer, please, accordingly. Find out something is common in all the examples. Keep drawing. Please note down all the examples. What is your observation in all the cases? What is the common thing that you observe in all the cases? Yes, E1, E2 multiple bonds. So if I say this is our E1, this is our E2, E1, E2 double bond, and E2 is more electronegative than E1. E2 is more electronegative than E1. E1, E2 double bond, even triple bond will also work. So I can add some examples as in this. Keep drawing. Check. In all these questions, you will find the same feature. And the feature is very simple, very clear. It's this. Observe what I'm trying to show you. Chinmay, is it okay? Niharika, Adya? Very good. So I hope this part is pretty much clear to all of us. In all these cases, we have E1, E2 double bond or E1, E2 triple bond, where E2 is more electronegative than E1. This is always going to be minus M group, puller. Now, when it pulls, what will happen? See, when you pull in this way, what will happen? So let's say you pull it like this becomes negative, this end becomes positive. Deficient ho gaya na, remember? You pull it like this becomes negative, this becomes positive. You pull it like this becomes positive, this becomes negative. Negative, positive. This pulls, and this pulls. Check please. ये chain बन गई पूरी. Alternate double bonds. This becomes positive and this becomes negative. Similarly, this pulls, this negative. Pulls, negative, 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 negative. कर लोगे? I hope you understood this concept properly now. Plus M means support with resonance or conjugation. Minus M is pulling with resonance and conjugation. Plus I means pushing with electronegativity differences. Minus I is pulling with electronegativity differences. Done? So this much is clear. You understood plus M, minus M properly. Now I'm again asking the same question. Minus M and minus I group. Tell me if you have both. Minus M and minus I group. इसमें है. Is it minus I? How will you decide is it minus I? It will pull. This 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 will pull. Pull, pull. Okay. देखो देख रहे हैं minus I सब में. Everywhere you have the same feature. All the groups which I have written here, coincidentally, they are all minus M and minus I. So my next question, you can guess. What will be the next question? Minus M plus I group. क्या ऐसा कोई है जो वैसे तो माइनस एम हो बट वैसे प्लस आई भी हो जाए? अब बताइए. यस, श्याम. Yeah, but that's not asking. So can there be a group which has both minus M as well as plus I? So generally speaking, this is almost null. Okay, this is almost null. We can have one or two examples we can create randomly, but as of now you keep it as null. Okay, very rare, very very rare. Okay, कि माइनस एम भी हो रहा है प्लस आई भी हो जाए, यानी आप बोल रहे हो कि भाई ये पुल भी कर रहा है और electronegativity is the reason behind minus M, in conjugation, and then it is pushing it back. So that's become null. Fine. These are the cases that you should know, and if it is clear, that means you understood plus M, minus M, plus I, minus M. Fine. All effects are clear up to this point. What is plus R and minus R? Plus R and minus R are exact as plus M and minus M as of now. So that difference we will discuss maybe sometime later once you are very much comfortable in organic. Then we can talk about that part. What is plus R? What is plus M? How they are small? What is the small difference in these two things? But that's not at the current point. Shall So if this is clear, I can move forward. Can I remove this? So in minus M cases, you're getting plus charges here, here, and here. And the same in plus M cases, you're getting minus charges here, here, and here, right? So how many of you can observe that in both the cases, you are getting charges. Let's say the G is a group. Let it be plus M or minus M. You're getting charges here, here, and here. Nobody's bothered about meta position. This is called ortho position. This is meta. This is para position. I hope you know this. Ortho, meta, para. So meta position, nothing is coming. If it is plus M, there is no charge coming up. If this is minus M, still no charge is coming up. Is it clear? But remember, if it is plus M, you are getting a minus charge here. Hence, these positions are activated to attack on electrophile. Because they are negative, they will look forward for E plus. When these positions become plus in presence of minus M group, like in this case, these positions become useless for electrophile. Hence, relatively, meta becomes better position. I repeat my sentence. If it is a plus M group, minus charges are appearing at these three places. Hence, these positions will try to involve electrophile on these places, right? But in minus M case, these positions which are marked as plus here, right? They're useless because how can plus attract plus? So the position which is not having plus becomes a better site for attack of E plus. Hence, meta becomes better. It's like, I'll give you a practical scenario. So let's say there is someone who is good in some particular sports activity and that person is not participating, and because of this, someone is getting, let's say, first. So it's basically because of absence of that, it is becoming first, right? Not because of the reason. Understand? So try to understand. In this case, meta is good for E plus, not because of its virtue or some property. It is good for E plus because others are much more bad or worse. Are you understanding this point? This is a very interesting point. Please try to understand. इस पे एडवांस का क्वेश्चन आ चुका है इसी स्टेटमेंट पे जो मैं बोला स्टेटमेंट. Meta position does not attract E plus because of its virtue. It attracts E plus because orthopara is bad. You understand this statement, please? Niharika, Adya, Chinmay. So be very careful about this statement. This is very important line. Are you sleeping properly? Why your eyes are red? Huh? But you look like very tired. What happened? Played a lot in school today. Take care of your health, everyone. Can I remove this? Akshay, written, Sanjana, Sham, Arav, लिख लिया इधर पे चिन्मय, निहारिका, आद्या, written. Very good. तो चलिए आगे बढ़ते हम लोग further discussion पे अपने. So our next discussion is, I'll just review it quickly and then we'll proceed. Now look at this diagram. I have shown OH. I have shown how charges will move. You know already. Please don't copy. You know this. You know this or not? How lone pair moves and all. So where is charge forming? This position, and this position. And you can draw the structure. Fine. You also know what are these groups. So already we understand this part. What is best for E plus attack? Plus M plus I, because it will make the ring rich. What is worse for E plus attack? Minus M minus I. Okay. Minus M plus I is rare. And yeah, that's all. Okay. Please note down this thing. VSA means very strong activator. Just write down. Very strong activator. Just draw this table. What is the meaning of very strong activator? So the meaning is simple, that if you have E plus with a plus M plus I situation, then ring is highly activated. Ring is highly activated. The ring is having lots of electron and they can easily go and attack on E plus. So we call it very strongly activated for E plus within bracket SEAR. SEAR I have done in the earlier classes. Can you recall? Electrophile आता है H को replace करता है. Okay, benzene ring पे you put CH, CH3, CH3 in all those cases we have done. Can you complete it? Great. So this table is basically a simple summary of our discussion. And whatever we are discussing is for electrophile. You can ask, sir, why it is electrophile? Why are you not discussing about nucleophile? Because benzene ring is rich with electrons. Hence, we can talk about electrophile. Okay. So try to understand, if tomorrow somebody asks a question that you have a group like this, which is O negative, and you have E plus, let's say in format of NO2 plus, or let's say in format of CH, CH3, CH3 plus. So what is the correct placement of these groups? So you'll say, fine, these groups are electrophile, this ring is rich and all. These positions are activated, I can place any of these three places. Okay? Understand? The same question comes, but this time let's say they give NO2. The question comes, you will try to put it here, if possible, right? Because ortho and para position will not be used. Sajna, is it clear? Arav, is it clear? And moreover, with NO2 it will become difficult also. Maybe nothing will come because this is highly deactivated. So maybe this will not react also. We'll talk about it. Is it fine? Chal. So आगे बढ़ते हैं अपना discussion पे. Minus M is pulling electron away from the ring via resonance. I have shown you examples earlier. You've written it down. No need to copy again. So technically, you have four possible scenarios: plus M minus I, plus M plus I, minus M minus I, minus M plus I. 1, 2, 3, 4. Out of 1, 2, 3, 4, plus M plus I cases are when plus M plus I cases I have mentioned O negative wala case, right? Plus M plus I case was O negative wala case. NH minus wala case, right? Minus M minus I cases we have seen earlier, right? A lot of minus M minus I cases we have seen. Plus M minus I case, I said it is a rare case, right? Okay. Now, this is lone pair part. This already we have discussed. Let's not go into this. NO2. Can you just practice one structure? You want to draw or you know this? You know this, all of you? Minus and plus I is rare. Plus and minus I, we have examples, a lot of examples. Please draw one of these at least. Just draw maybe NO2. Okay. Just draw NO2. Don't look at here. Do it yourself and then check. Just for practice. I know you know this, but just for practice. Please draw resonating structure of NO2. And remember, in all the cases, I'm drawing 5 structures. 5 resonating structures. Okay. Please complete it. ठीक है? You please draw and then check. So if you remove plus comes here, then here, and then eventually you have to give it back. Normal structure. See the first one, the last one. You'll find the alternate placements of double bond. कर पा रहे हो खुद ही अपने आप? अगर कोई भी mistake आपने की है, then please do it for CN also. कोई भी mistake किया तो CN के लिए भी बना लो एक बार. कोई दिक्कत वाली बात नहीं है. Niharika, I hope you're doing this.
Yes, sir.
Okay, good. Chinmay, done? Good, good, good. Very good. Can I proceed further? Anyone having any doubt, please ask. Shyam, any doubts in the bond movement? I think now you're comfortable with bond movements and all. These things you understand very well. क्या हो रहा है, movements and all, because this will be required in 12th standard again. So please work upon these things. Look at for CHO. Look at for CHO. Same thing. Look at for CH double bond NH. यहाँ पे lone pair थोड़ी है, तो this will also pull. Can you understand all these structures? How I'm drawing? Look at for CO. If you want, you can please copy, just for practice. If you have any doubt, any trace of doubt, you can just copy these structures. But I'm pretty sure that you know most of the things, and you can do it yourself. I hope my assumption is not wrong. Let me just check. Who I draw? Sanjana, done? So while doing it, you have to move this also here and this here. So यहाँ से इसको भी लेके आइए. अरे रेड से लिख रहा हूँ, ब्लू ले लो यार. Why are you writing with red pen? Okay. Done? Done, Sham? Good. Yeah, so last one, send it here, send it here.
That's the same.
Yeah. So I think all these cases are pretty much similar only. ये ऊपर चला गया. CN is also called sigma to p vacant orbitals. ये ऊपर चला गया. And you have understood also. Anyone having any confusion, please ask. Chinmay, any doubts? Niharika, Adya in this line? SEAR reaction, E plus reaction for plus M is OP director, minus M is meta director. Any doubt in this? No doubts? Chaliye. Write the heading hyperconjugation in detail. We have to do hyperconjugation. Hyperconjugation. Point number 1, जो सबसे पहले मैं लिखवाना चाहूंगा, note down that point. Conjugation is more effective than hyperconjugation. तो बोलोगे सर ये हाइपर है, फिर भी आप बोल रहे हो conjugation ज्यादा strong है. So don't go by the word, don't go by the English meaning of hyper. Hyper means, yes, hyper means higher, ऐसा लगता है. But hyperconjugation is not superior than conjugation. This is the first common mistake with 90% students. Okay. So first point आप लिख लो, conjugation is superior than hyperconjugation. पहला point तो यही है, basic. Now what is hyperconjugation? This is also known by various other names, by the name of the persons who found Baker and Nathan. So Baker-Nathan effect. No bond resonance. Normally we don't see a kind of bond moving and that kind of thing that is normally there in double, single, double and all. So it's called no bond resonance. This is also called sigma to p vacant orbital support. Sigma, but I'll explain you everything, don't worry. Sigma to p vacant, that's why it is also called sigma to p vacant. Conjugation is superior than hyperconjugation. Inductive effect in conflict with hyperconjugation. Inductive effect will lose, hyperconjugation will win. And the final sequence is conjugation, hyperconjugation and inductive. CHI. Okay. China याद है ना, China का CHI. हाँ. Mesomeric will be somewhere. Mesomeric is conjugation only. What is mesomeric? It's conjugation, no? It's resonance, right? Please complete this. Note down all the points. I'll explain you what is meaning of this and this. I think इसमें तो कोई confusion नहीं होगा. इसका नाम ऐसे भाई नाम है. इसमें भी confusion नहीं है. इसमें भी नहीं है. एक ही confusion हो सकता है, which is on these 2 points. And then one more point. Hyperconjugation can be of 2 types: plus H and minus H. Plus H and minus H. Mesomeric can be plus M and minus M. Resonance can be plus R and minus R. Inductive can be plus I and minus I. Likewise, hyperconjugation can be plus H and minus H. ठीक है? Minus H को बोलते हो आप reverse hyperconjugation. We'll talk about this also. Reverse hyperconjugation. Next 1.5-2 months, we have to put lots of effort because you have done everything. Now you have to just brush it up and go in 12th standard with full energy. So we should not leave any stone unturned. पूरी energy से जाना है. 11th अच्छे से यही पे complete करना है. We should not be a student की जिसने 12th में भी 11th revise कर रहा है या 11th के doubts पूछ रहा है. No, we have to finish it off here itself and then move to 12th standard. That should be the aim. So 15th March to 31st March, we'll be giving you a complete review of 11th standard, complete revision of 11th standard. 15 to 31, physics, chemistry, maths, all. So let's say daily one topic will be completed, something like that. Or let's say in 2 days one topic will be completed. Okay, तो उस पैटर्न पे हम लोग प्रैक्टिस करेंगे, थियरी करेंगे सारी, and then further it will be taken up. Is it clear? So idea is that 1st April when you enter 12th standard, you should know everything in 11th properly. वहां तक आपका सारा रिविजन, रिव्यू, कुछ टॉपिक छूटा है, कुछ पढ़ना है, सब बता देना, सब करा दिया जाएगा. कुछ आपने मिस कर दिया, कुछ आपको समझ में कम आया, you please tell us upfront that this is the problem, we will solve it. Okay, is it clear? And then once you enter 12th standard, you should go with full energy that yes, I know everything, now things are clear. Done? Chinmay, Niharika, Adya, is it clear? Chali. So let's understand what exactly is hyperconjugation in real sense. So let's do it. Okay, let's do it. Hyperconjugation. Write few points, few more points. You've written only few points. Add few more points. This is used to explain. This is used to, or this theory is used. See, this is a theory, right? Hyperconjugation is a concept, it's a theory. This is used to explain stability of carbocations, stability of carbocations, comma, stability of alkenes, stability of alkenes, okay, and stability of aromatic compounds connected with alkyl groups. Aromatic compounds connected with alkyl groups. I'll explain how and why. So I hope you have written carbocation. This is how we can talk about hyper without mistake. And hyperconjugation. ऑफलाइन वाले आ गए, ऑनलाइन वाले क्या, तीनों ही गायब है. हाँ, it's already over, right? हाँ, 317. Chinmay, Niharika, and Adya, can you hear me? Chalo, let's start then. So if you see, the one which is having maximum number of alpha hydrogen will be the most stable. Then second, then third, then both are zero. So they will be like fighting for fourth placement. Now, which is worse? This one is bad or this one is bad? How do you decide? Now, this is very bad structure. Why? Because on C plus you are putting so many groups. which is a good amount of, there's a word used for it, steric crowding. Steric crowding, note down. Steric crowding means lot of traffic basically. So due to this plus charge will be highly unstable. You're putting so many CH3s like this, it will make the whole system unstable. So ये words चला जाएगा, इससे भी ज़्यादा, ठीक है? This one is best. 1, 2, 3. Okay, because of 9 alpha H. So alpha H is the guiding principle for stability of this. More alpha H, more hyperconjugation structures. No, vacant orbital is one only. More H can support. This can also support. This can also support. This can also support. That's what we discussed before break.
Okay.
Yeah, same thing. C plus.
I got it.
Can I recall? This. Okay. So this is the first case which is telling you about carbocation stability. Chinma, are you back? Now coming to the next case. इसको पहले एक बार नोट कर लीजिए. Can you proceed further? चलिए आगे बढ़ते हैं. So I'm removing it, considering that you understood this. So quick review of hyperconjugation. This part is clear. This is also clear. How do we count alpha H? That part you understand. Now I'll come to the double bond part, but before that, this is also clear. This is more stable in the sequence. This kind of question, 6, 3, 2. 3 is better than 2. Remember, this is ethyl group, but methyl becomes better. Normally, inductive effect will say ethyl is better. So this is a fight between inductive and hyperconjugation. Inductive says this is better. Hyperconjugation says this is better. Who's the winner? Hyperconjugation. So actually, this is better as compared to the previous. Is it okay? Please note on this example. And then we go to these kind of questions you can easily answer now. How many alpha H are there? Should not be a problem for you. Then I'll come to stability of alkene after this. Please note down this. Then I go to stability of alkene. Complete this. Note these examples. Clear, Sham? How was your score this time in chemistry exam? All of you. Out of how much it was? 25. कितना स्कोर किया था? भूले तो नहीं होंगे. ऐसा बोला कि मैं भूल गया. What was the score, Sanjana? 19. आपका अक्षय जी? 17. 18. 17. इधर ऑनलाइन वालों के क्या नंबर थे केमिस्ट्री में? भूल गए या याद है? या आवाज नहीं आ रही? आवाज नहीं आ रही. चलो कोई बात नहीं. ठीक है, कोशिश करो कि इसको इम्प्रूव करो. पेपर वाज डिफिकल्ट. 25 क्यों नहीं है किसी के? 25, 24 क्यों? डिफिकल्ट था पेपर.
No one got it.
What is the highest? Who?
Top sharing, sir.
Okay. Done? Any doubts in this? Can I go proceed further? चलिए लिखिए next. Stability of alkene. Yeah, this is 2 alpha hydrogen. This is 3 alpha hydrogen. No, alpha. This is beta. So 2 and 3. So I'll mark this as better. But as per inductive effect, this is better. Okay, because ethyl inductive effect is considered better as compared to methyl effect. But who's the winner? 3 alpha H, hyperconjugation. Whenever there's a conflict between hyperconjugation and inductive, the winner is hyperconjugation. यही सीखा हमने, right? चिन्मय, आर यू बैक नाउ? बहुत दूर निकल गया लग रहा है. चलो, let's see whether he's back in the class. Anyways, coming to the next part of the story, that is alkenes. Yeah, एक बार check कर लेते हैं. Can you hear me, Niharika and Atif? So what was the score in chemistry, if you can hear me? अभी नहीं सुनाई दे रहा. Okay, चलो. Let's not disturb them. Write down stability of alkene. This is second application of hyperconjugation. लिखिए. Second application of hyperconjugation is stability of alkene. You can tell about stability of alkene. So now, first application was the previous one which you have done, stability of carbocation. So let's say we have these structures. Please draw. And थोड़ा speed में draw करने की कोशिश करो. Calling it 1, 2, 3, 4, 5, 6, and 7. Please draw without mistake. कुछ गलत मत draw कर लेना. Chinmay is back. What happened, Chinmay? Where were you?
So I was here, I forgot to turn my camera on.
Okay. Please note down this. Done. So just see the first example, for instance, or let's say we can take this one. If you give it H plus, how will it look like? If you give it H plus, it will become H plus CH3, H and hydrogen. That can be one option. Or it can be H These are the two probable options. Please draw. These are two probable options. या तो यहाँ पे प्लस चार्ज आएगा, H इधर आ जाएगा, यहाँ पे प्लस चार्ज आएगा, H इधर आ जाएगा. यही तो हो सकता है, दो ही चीज हो सकती है. Now please tell me, out of these two structure, which will give you more hyperconjugations? If you see this structure, this is alpha carbon, there are two alpha H. And look at this structure, there are this is alpha carbon, and this is also alpha carbon. That way. Can you observe? So which position is better position for plus charge? This position. ये भी आप इससे ही तो बता सकते हो easily, right? So when you discuss stability of carbocation, you can again take help of this method while deciding it. That's one criteria. Is it okay? How many of you understand this logic? What I'm trying to convey? Second important thing. If I consider this C double bond C as a pi orbital, right? And let's say you have a CH here. Out of 3 CH, I'm drawing it like this. So this is a sigma and this is a pi. And when you want to discuss any kind of hybridization in this, what is the possibility? Possibility is if I break this bond, keep negative here, keep positive here, I can again talk about hyperconjugation. Because when a double bond breaks as a minus and plus, the plus and the next carbon with alpha hydrogen, we can talk about hyperconjugation. This is how we can talk about hyperconjugation for this particular scenario or stability of alkene. So if you see this C double bond C, these are my alpha carbons and these are alpha hydrogen. So 3 plus 3, 6, 3, 9. If you see this one, 3, 3, 6. If you see this one, 6. This one, 3 and 3, 6. This one, just 3. This last one, 0. And the first one, 12. Do you understand this? This is how we count alpha hydrogen. So you have C double bond C. You'll go to this position count and you go to this position and also count. Both side you're counting. इधर का alpha ये मिला और इधर का alpha इधर मिला. Is that clear? Chinmay, Niharika and Adya, is it clear? How do we count alpha? And logic behind is also clear because we can give H one side and give H other side. So out of 1, 2, 3, 4, 5, 6, 7, if you have written, all of you have written 1, 2, 3, 4, 5, 6, 7, which is most stable alkene among these? Your answer would be 1 better than 2, better than 3, better than 4, better than 5, 6, 7, 8 and 9. Now, this is the order of stability. Please note down. Question comes, why and how? Because 12 is bigger than 9, understandable. 9 is better than 6. 6 is better than 3. 3 is better than 0. That's okay. But how will you decide this 6, and this 6? That can be a key question here. These all are 6. So how I'm telling that 3 is better than 4 is better than 5? This is the problem area. Yes or no? Because all are 6. How are we deciding that 3 is better than 4 is better than 5? Because in 3, if you draw 3 carefully, you can get this possibility. So see, all 6 alpha H are present on same carbon. Hence, it can form a 3-degree carbocation. Are you understanding? That means its hyperconjugation is more stable as compared to other two, where one will be 3, other will be 3. I'm counting 6, but this is 3 and 3 separate. This is 3 and 3 separate. This is 6 together on the same carbon. So I hope this is clear that this 3 is better than 6 together is better than 3 plus 3. अब क्वेश्चन आता है why 4 is better than 5? Because 4 is trans. Trans senses आपने पढ़ा हुआ है. Trans is more stable. Trans is more stable. The reason is this is having diagonal symmetry. CH3s are away from each other. They will not create any repulsion, hence become stable structure. Okay. So trans के लिए क्या क्या चीजें अच्छी होती है? नोट कर लो एक बार फटाफट. Trans के लिए क्या क्या better है? Trans has better what? Tell me. Let's. Trans has more symmetry. Note down. Trans has more symmetry. Trans has higher melting point. I repeat, trans has more symmetry. Trans has higher melting point. Trans will have lesser boiling point. चलो इसको mix मत करो, confuse हो जाओगे. Just write higher thing first and let other one I'll write for the other high, right? So trans has more symmetry. Trans has more melting point. Is that okay? Now coming to cis. Cis has so mono, di, tri, tetra. Welcome everyone. Welcome to your own channel, Mishra JEE NEET. Greetings everyone. degree of quantity. Is that okay? Degree of chaos. We can minimize because nobody's there, right? So we can minimize that window. No, the first one. First one. Yeah, perfect. Yes, perfect. So, degree of disorderness, degree of randomness, or degree of chaos. What is the meaning of it? See, you observe anything. Let's say, for instance, we take a glass of water and we stir it well, like with some spoon. Let's say we just start moving that water. What will happen? You are going to create more randomness in the still water. Okay, you throw a stone in a stationary pond. What will happen? Waves will be created. Okay, they will move from center to periphery. That means you are creating randomness or disorderness. In simple words, if you introduce anything in nature, that always creates randomness. You do whatever process. Let's say I'm just raising my hand. It's increasing entropy of universe. Whatever you do, it will increase entropy of universe. So all the natural processes will always be irreversible and they will always increase entropy. It's a very valid fact. ठीक है, अभी इसने गर्दन हिलाई तो इसने entropy बढ़ा दी universe की. You are again doing this, you are increasing the entropy. So whatever you do, you are always increasing, you are adding on entropy of universe. Okay. Global warming, climate change, सब क्या है? Entropy of universe is increasing. It is tending to the maximum value, right? Increasing, where there is no limit, right? It will keep on increasing. Is that clear? So that you have to understand. Now, next part. When solids become liquid, then Sanjay, some practice, I think.
Music.
Okay. Interhouse. Okay, what is interhouse?
Like we have houses in school.
No, so there is some function going to happen.
No, so we have competitions, inter-house competitions.
Acha.
Yeah. So music.
Solid to liquid, what will happen? Can we say entropy will increase? Liquid to gas, entropy will increase. Liquid gas to convert होगा gas की energy ज़्यादा है. Okay, just simple. S, capital S. Gas molecules are increasing. What will happen? Right, because no person आराम से chill कर रहा होगा, right? So entropy of the person is what? Less. Entropy of the room is high. So yeah. So person. It's an ideal hypothetical situation of gas NO and 1 mole of gas N2. Provided we have so pressure will increase. If you increase pressure, temperature will increase. That's one case, right? Other cases, increase the pressure, temperature is constant. That's a case number 2. If temperature is constant, we know that if pressure is increased, volume will reduce. Because P and V are moving in opposite direction, right? So if pressure is increased, temperature is also increasing, then entropy will increase. But if pressure is increased, temperature is constant, volume is decreasing. Now see, you have this vessel. You are increasing pressure. Vessel's volume is lesser now. So the molecules are moving in a smaller volume. Are they paying attention to this? So this volume is becoming half, let's say. Now they're moving in half of the volume. So what will happen to the entropy? It will be reduced. Both the cases note down. Pressure increase, temperature increase. Pressure increase, temperature constant, volume reduce, entropy will be lesser. Temperature increase, it will increase. Atomicity is higher, entropy is higher. So let's say you have 1 mole of gas NO and 1 mole of gas N2. Provided we have the same atoms. Don't compare N2 with CO2. I'm comparing NNO with NNO, different combination. So NO and N2, if you compare, N2 will be higher because N2 has more number of atoms, right? So more degree of freedoms will be involved. More number of atoms are involved, right? So randomness will be higher. Note down this also. So these are certain points for entropy or disorderliness. Any difficulty in this?
The first one, if you go from liquid to solid, entropy will decrease.
Liquid to solid will be decreasing.
So, but noise will anyways come out because it's shared space. So one noise always comes because the space is shared.
No, you should not shout. Shout like that. You can do work, there's no problem. Does not work. No? We are also doing. My voice will not go outside. So entropy of system plus entropy of surrounding is entropy of universe. Right on this point. Entropy of system plus entropy of surrounding is entropy of universe. So basically, system plus surrounding is universe. Okay. Note on the point one. Entropy of system plus entropy of surrounding is entropy of universe. Change in entropy of system plus change in entropy of surrounding is zero if it is a reversible process. Okay. So basically, reversible process, what is going to happen? By default, reversible process does not do any change in entropy of universe. But reversible is hypothetical. It's an ideal situation. So if system is increasing, surrounding will decrease. If system is decreasing, surrounding will increase. Understand? So let's say one is increasing by x value, other will decrease by x value. Or other is decreasing by x value, other will increase by x value. Overall, they will say plus x minus x is 0. Or minus x plus x is 0.
So why is reversible?
Irreversible. Because reversible processes are not building any kind of entropy. Why it is not building? Because for reversible case, you have proved integral ds system is what? 0. Few minutes back we have discussed, right? That Carnot cycle part. So integral ds system is 0 means what? It's a state function. And for that whole part, if you just move across, it's not changing the universe things, right? Come to the next part. In nature, all processes are irreversible. In nature, all processes are irreversible, and entropy of universe is ever increasing to become maximum.
So what will happen if it reaches maximum?
It will not reach maximum. It is always tending to become maximum. That's why the word is ever increasing. Okay. It's like it's just keep on shooting up. Okay. And in nature, there is nothing reversible. Even if you say it is reversible, it is not correct, right? Everything is irreversible in nature. You can say water cycle is there, you can say nitrogen cycle is there, but these are cycles. They're not reversible process. It's not like the water which will be evaporated in exactly same way it will come back and all. No, it's just a cycle, right? No reversibility is ensured in any process of nature. So just to summarize the whole discussion, in nature, everything is irreversible. Since everything is irreversible, for all the cases, entropy of universe is increasing. If entropy of universe is increasing, it is tending towards the maximum value, right? Any difficulty in that part? Any issues in this? Okay. So, can we say delta system plus delta surrounding is non-zero for natural process or irreversible cases? Or can we also say it is more than 0? Okay. Delta system plus delta surrounding is 0, which is for delta's universe, which is reversible case. So this is the summary of our discussion.
You can't have entropy negative.
Entropy of system or surrounding?
Anything.
It can be negative, why not?
Like entropy of the universe.
Universe cannot be negative.
It cannot be negative.
Universe cannot be negative, for sure. Universe, the best case scenario is 0.
When
Best case scenario is 0 if it is reversible process.
so that's when maybe like entire universe is at absolute zero, then nothing happens at all. Then
Yes, we can say, see, reversible process, इसको थोड़ा और deeply समझो. Reversible process means what? Everything is having quasi-static.
some movement.
Okay? Infinite is similarly slow. So आपने एक बार यहाँ से let's say उसके ऊपर रखा एक m mass रखा dm mass, it's moving very slowly. It's not doing any exchange with surrounding. So in such processes, universe entropy is as it is. It's not changing. That is only reversible processes. So ये पूरी बात पर समझ में आनी चाहिए. First result clear, then we can proceed further. So now if it is clear, let's come back and write case by case करेंगे, solve करेंगे questions and try to understand. Write down the first question. 1 mole of an ideal gas is expanded isothermally. 1 mole of ideal gas is expanded. I just get what? Isothermally.
Is that same question? Just came the
करिए सॉल्व करने की कोशिश करिए.
So if processes
If processes reversible, second
Oh.
is irreversible. दो questions हैं. अब फॉर्मूला आपको सारे पता है. How do you get delta system? So you know ds is dq by d. ds is dq by d for reversible case. dq मेरे को पता है isothermal का कितना होता है. नहीं dq no होता है, du 0 होता है. du is dq plus dw. dq is minus dw. And minus w is pdv. Because dw is minus pdv. और p का वैल्यू कितना है? Minus nRT upon v. If you talk about ideal gas. So रखो और solve करो. बताओ delta system का फॉर्मूला क्या है?
what's the formula for S?
ds is dq upon d.
Or
Right.
DQ?
ds is dq upon d. dq की वैल्यू वहां से रख लो.
Reversible.
Reversible.
DQ minus DP.
dq is how much? du plus pdv.
Yeah.
du तो 0 हो गया.
0.
So pdv upon p is how much? For ideal gas. nRT by v.
Can't I use D find the work done?
It's okay.
It's okay.
So then you integrate.
P is nRT capital letter. T capital letter. And see, this is upon v. So this whole thing upon v. This side you have done upon v. This side also you should upon v. The whole thing. Or you say just this is dq. Just cut t here. dq is du plus v.
Yeah, that's why that.
Integral. This is what you wrote is ds. This is ds. Now get delta s. Integrate both sides. कितना आ रहा है?
10 no, wait, 10.
Give your answer in terms of what?
10.
RL 10. Good. This is what delta s.
Just
So right, delta system is RL 10.
the surrounding is minus 10.
Minus RL 10.
Because the surrounding is 0 for the reversible.
DQ का पहले वहाँ सब्स्टिट्यूट करो, T से T कैंसिल हो जाएगा. dq upon t में जो upon t और ऊपर जो t था वो cancel हो जाएगा. So your formula should come nr ln v2 by v1. ऐसा कुछ formula आ रहा हो integrate करके.
Sir,
Yeah.
but is it possible S equals Q by T?
No, ds is dq by t. That's for reversible case only you can apply this.
But is it possible?
You can't apply this.
That must be.
Think.
Sir, minus ln n.
Huh?
Minus ln.
For system.
Yes.
Why minus system?
Plus.
Then minus n.
ds is dq. dq is how much? dq is
This is something.
p dq. तो minus n यहाँ पे कैसे आ गया?
Because p is minus nr.
नहीं, p is not minus nr. p is nrt by v.
Oh.
और r is छोटा कहाँ से आ रहा है? r तो universal gas फंक्शन होता है. r कैपिटल करो. r कैपिटल. R पहले लिख लो. So ln10 r में ना वो ऐसा लग रहा है r उसके अंदर चला गया. Or you put a bracket ln10 then bracket and then keep r outside. You getting the same answer? No? Sure. What you've done? dq is minus dw. dw is minus p dv. So you put what is dq? अच्छा dw is solve करने पहले.
Right.
dq is minus dw. So यहाँ पे plus pdv हो जाएगा.
What?
dw is minus pdv. Minus or minus pdv is what? Plus pdv. So dq is what? nrt by pdv. ds is what?
Okay,
dq by t.
Minus this value.
ds निकाला फिर. So this upon t, t cancel हो जाएगा. So बचा क्या? nr dv upon v. nr dv upon v का integral nr ln v2 by v2. Complete. Complete and show. Go to irreversible case. Cut it. Write on the next page. No problem. R ln10 is delta S system. What is delta S surrounding? Minus R ln10. What is delta S universe? 0. So पहला आप देख लो solution. आपने ऐसा लिखा ds is dq reversible upon t, dq reversible is du plus pdv upon t. pdv को लिख दिया आपने nrt upon v. Just see. Integrate किया integral ds system is this formula. ये formula note कर लीजिए. Directly use कर सकते हैं. Delta S system is nr ln v2 by v1. किसके लिए valid formula? Isothermal reversible case. ठीक है? Direct formula is valid. If you see the Q value, it was nRT ln v2 by v. Check your answer because that was t times that number, right? ln 9 by 10.
For the second dice.
ln Q1.
What is it also?
Or no, ln won't come actually because you don't integrate.
Now see the next part. Minus delta surrounding was delta system. Delta surrounding of minus nr ln v2 by v1. Delta universe comes 0. First part is clear. Everybody. पहले यहाँ तक कंफर्म हो गया. कोई प्रॉब्लम नहीं होता है. Any issues? Any problem? Any difficulty? No issues? अब irreversible try करो. सोचो कैसे निकाल सकते हो. शाम समझ में आद्य everybody clear? चलिए second part की तरफ बढ़ते हैं. Try to answer second part of it. एक बात बताओ. In reversible case, what is the starting point? What pressure and what temperature? What volume? Temperature is 0, correct. But what was the initial pressure?
10.
Okay. What is the final pressure?
1.
In irreversible case, what is the initial pressure?
10.
What is the final question?
1.
In irreversible, what is temperature change? Irreversible.
0.
0. Same temperature. Initial, final temperatures are same. So what will happen to volume? Pressure is same. Temperature. Initial and final. Whatever initial volume was there. No, whatever initial volume was there for reversible.
Yeah. Oh, volume will increase.
And you're going to irreversible. Whatever is the volume and reversible. Same will be the volume for irreversible also. Value Y will it be same, D same. So we will the same over. Top and bottom we will not match. I'm not telling that. I'm saying that reversible starting point, irreversible starting point are same. Reversible endpoint, irreversible endpoint are also same. Do you agree with this? And this property, delta system is a state function. So देखिए, delta system is a state function. If it is a state function, does it matter that you go from reversible route or irreversible route?
No.
So what is the answer?
Same.
So delta system will be same. लिख लो. Delta system is a state function. Just see this, what I've written. Write like this. Delta system is a state function. You are starting from 10, 300 to 1, 300 in both the situations, be it reversible, be it irreversible. So since my endpoints are same, my delta system will be same. Since it is a state function. समझ में आ रही बात है? बहुत बेसिक सी बात है, कर लोगे इतना? तो आंसर क्या होगा फर्स्ट पार्ट का? RLN10. No second thought. Delta system is NRLN V2 by V1. ये फॉर्मूला लग जाएगा. N is 1, R is R, ln V2 by V1 is P1 by P2, P1 by P2 is 10 by 1. So answer is RLN10. सीधे सीधे कर लोगे. ये समझ में आता है V2 by V1 is P1 by P2. Because P1 by P1 is P2 by 2. Because T is constant. I hope this part is clear. अच्छा जी. What is delta S surrounding? Now this is interesting. So right now, delta S surrounding is written with minus Q irreversible upon temperature. Note. Delta surrounding is minus Q irreversible upon temperature. Minus Q irreversible upon temperature. Where Q irreversible indicate heat exchange with the surrounding. Q irreversible indicates heat exchange with the surrounding. अब आपको मैंने फॉर्मूला दे दिया, यहां से आप खुद सॉल्व कर सकते हो. बोलो डेल्टा यूज क्यू प्लस डब्ल्यू. अच्छा जी, डेल्टा यू खुद कितना है? हाउ मच इज डेल्टा यू? 0. तो क्यू कितना हो जाएगा?
Minus
माइनस डब्ल्यू. सो माइनस क्यू क्या हो जाएगा?
W.
डब्ल्यू. और डब्ल्यू का वैल्यू कितना है रिवर्सिबल केस में? हाउ मच इज डब्ल्यू?
Minus RC I think.
नहीं भाई, इरिवर्सिबल आइसोथर्मल चेक करो.
And then minus.
Minus NRT and then
माइनस पी एक्सटर्नल V2 minus V1 is the work done.
1 minus 1 by
Minus
P.
P external V2 minus V1 is the work done. So P external V2 minus V1 is the minus work done.
Yeah.
That value you can put, right? Solve the numbers.
So you get minus NRT and then 9 by 10.
LN कहाँ से आ रहा है? अभी LN कहाँ? ये तो मैं बोल रहा हूँ. LN क्यों आ रहा है?
So if you
इसमें LN कहाँ है बेटा? क्या बोल रहे हैं?
sorry, so 9 by 10
9 by 10 R. Plus है ना minus sign?
plus
फिर से सोचो.
minus
Minus Q irreversible upon T. Minus Q irreversible upon T. Pressure is becoming 10 to 1. Pressure 10 से 1 हो रहा तो क्या हुआ ये केस? Expansion का केस हुआ ना?
Compression.
So do it. सीधे कैसे लिख दिया आपने? लिखो तो यूज करो. हाँ?
I know.
Right here, no? What do you know? I also want to see. मन में कर लेता आधी चीजें. Is for?
Irreversible.
So this is whose formula? This is for?
But this is the work done in irreversible case. Isothermal.
So upon PV
And for S.
P external is P2.
P external can be taken as P2.
So that's 1. And V2 minus V1. It's 10 minus 1 because you take ratio of.
No, that is pressure. It's not volume. We have to put V is nRT by P. करो solve करो. So you can say delta U is Q plus W. You see, minus Q upon T is W upon T. W is minus external V2 minus V1 upon T, right? Values हो जाएंगी सारी. Then you'll put the numbers. P external is P2. इसको note कर लीजिए पूरा एक बार. And V2 is nRT upon P2. V1 is nRT upon P1. Upon T में सारे T cancel हो जाएंगे. NR बाहर चला जाएगा. N का value 1 given है. R है. अब values रख लीजिए. Try to simplify the whole thing. P2 is 1. So P2 upon P2 is 1. Minus P2 upon P1 is 1 by 10. So 1 minus 1 by 10 is 9 by 10. R is the 9 by 10 R. Check करके देखो सारी values. This number, if you solve, you should get this, which is this, which is this. Please confirm. हो गया? Complete कर लीजिए. Complete. Okay. कर पाएंगे. कोई भी प्रॉब्लम यहाँ तक तो बताइए. नो प्रॉब्लम. कितना सॉल्व में आया पूरा क्वेश्चन? रिवर्सिबल, irreversible, नो डाउट. वेरी गुड. चलो अब ये समझ में आ गया तो एक आगे बढ़ते हैं. वन स्टेप अहेड. सॉल्व. Delta surrounding is defined as minus heat exchange from surrounding upon temperature. So this again comes from other relations in thermodynamics. So we can use that direct formula. Delta surrounding minus Q exchange with surrounding upon T.
The both these are only for isothermal.
No, this minus Q exchange upon T is for everywhere. But the front one is like will change.
This is only for.
Yes, it will change case by case. So try to answer this question.
So you can use this formula for what's reversible irreversible.
So the standard formula is TS system is dq upon T.
Okay.
That is always visible. And the standard formula is Delta surrounding is minus Q irreversible upon T. That can always be used in all the cases. So try to use it.
Then why do they specify non-linear triad?
Gamma is 4 by 3. I gave you gamma directly 4 by 3. But it's a non-linear thing. It will have degree of freedom, translational 3, rotational 3. You've done right?
Yeah.
And vibrational will be 3 and minus 6. But vibration is non-active, so only 6 will be considered. And gamma is 1 plus 2 by n. F is 6, so 1 plus 2 by 6 is 4 by 3. I gave you directly gamma is 4 by 3. Gamma is also called Poisson's ratio. It's called Poisson's ratio. Why are you applying formula?
Find final temperature.
And why are you doing that?
Because
Isn't temperature constant?
No.
I know. It's just zero.
एडियाबैटिक
Just
क्यू
check.
0 है तो सॉल्व क्या कर रहे हो आप लोग एडियाबैटिक का क्यू कितना होता है 0
Yeah.
तो dq अपॉन
So
t क्या होगा 0 अपॉन
zero.
t 0 अपॉन t कंटिन्यू होगा 0 कुछ सॉल्व भी नहीं करना है इसमें सो रिवर्सिबल केस डेल्टा सिस्टम इज 0 डेल्टा सराउंडिंग इज 0 डेल्टा इज यूनिवर्स इज 0 सो पहला तो ऐसे सॉल्व किया
So for all
Come to irreversible.
irreversible.
Huh?
For all identified, they get like that.
for reversible part all three are 0 0 0 and 0 yes or no why surrounding 0 because it's not exchanging heat from surrounding adiabatic is a cut off no so surrounding से तो exchange हो ही नहीं सकता so 0 हो जाएगा so delta system is 0 because dq is 0 dq upon t is your formula no dq itself is 0 the integral of dq upon t क्या होगा 0 ही होगा ना ये भाई लगा हुआ बिल्कुल सॉल्व कर देगा सब कुछ तो so note down delta system is 0 delta surrounding is 0 delta universe is 0 नहीं तीनों नहीं से होगा लिखो पर लिखो लिखो प्लीज राइट डाउन बाहर अरे अभी अंडरस्टूड है 2 महीने बाद ये सब अंडरस्टूड से अंडरगॉन हो जाएगा लिखो लिखने में बहुत आप लोग पेन लेते हो देखो इसकी फॉर्मूला बनने बड़ी
Everything is there.
yeah everything is there that is a good formula no all formula you can revise
Like not just formula.
and the questions are also there
Yeah.
okay good चलो irreversible case solve करो
Sure, but delta Q is just zero, right?
हाँ but मेरा formula क्या ds irreversible is can I use ds irreversible as dq upon t no I can't that is not that is only valid for ds system is dq reversible upon t it cannot be dq irreversible upon t now in the previous case it was same because our pressure and temperature conditions were same is this same this time also is the temperature of reversible same as reversible are you reaching to the same end condition answer is no
Now you need to calculate that.
हाँ अब कैलकुलेट करना होगा नहीं वो वाला नहीं वो नहीं चलेगा बिकॉज वो रिवर्सिबल का है
P to the power 1 minus gamma.
वो नहीं चलेगा दैट इज फॉर रिवर्सिबल द अदर वन व्हिच इज फॉर इरिवर्सिबल
230 times. Is temperature.
सॉल्व कर ले भाई सॉल्व करके दिखाओ
Minus P external.
minus p external v2 minus v1 is ncv t2 minus t1 then we put t1 t2 is not known v2 minus v1 is nr t2 upon v nRT 2 upon P2, nRT1 upon P1, all these values you put, simplify that and solve that equation. Get temperature. Huh? No, solve.
So T is minus T1 by gamma minus 1.
It's the same.
Solve.
The same value.
Solve.
So 16,300.
Solve.
That's a form. That's T2 minus T1 by gamma minus.
Huh?
T2 minus T1 by gamma minus.
We simplify. You can always simplify. The formula is NCV T2 minus T1 is minus K external V2 minus T1.
First the same value.
हाँ तो एक बार सॉल्व करो यार क्या क्या है एक बार और सॉल्व कर लो प्रैक्टिस चाहिए होगी आपको कोई आ रहा है उधर से
So you know that wall is about to fall down, like
Yeah.
the other room, the big one, before like that door thing, the entire thing is shaking. Like it's loose from top. Like the AC vent also
Yeah.
fell down.
Yeah, then they put it back.
Aditya closed the door. Normally only, not even had it fell. Then we tried putting it back and then
करी
For 230.
repeat it good इतना ही करना है
that's what you're finding.
That.
Oh,
You're finding.
T2 ही निकालना है once you get T2 you will know the end condition फिर क्या करना मैं बताता हूँ पहले आप T2 को मापिए
Oh, I don't know what to do.
no if you can try but
Is that a formula?
no we will derive a formula sorry कैसे पता है इतना ही होगा सॉल्व सॉल्व करो T2 बहुत शॉर्ट शब्द है भाई बच्चों
This one doesn't go there.
ये शक्तियाँ आपके पास ही है दिव्य शक्तियाँ अलौकिक शक्तियाँ इतनी दूर का सोचना बड़ा मुश्किल है कुछ तो गड़बड़ कर दिया माइनस कैसे आ गया हम
No, this is minus.
हाँ ठीक है 900 on this कुछ गड़बड़ है हाँ not this one that is 300 or 800
300 by 60. Yes. 980. 9. Oh.
So
first everyone reach to that level
So 2 to 9 point something, so you round down.
so see the first case एक बार मैं रिवाइज कर देता हूँ reversible case DQ 0 DQ upon T 0 DS system is DQ upon T 0 delta system is 0 delta surrounding is 0 delta is universe is 0 ये तो reversible हो गया सॉल्व कोई प्रॉब्लम्स क्लियर irreversible में आ जाओ DS system is not equal to DQ irreversible upon T you should be very clear about it ऐसा कोई फॉर्मूला नहीं so end points of reversible and irreversible are not same लिख लो उसको नोट करो Your endpoints are what? 16 atmosphere, 300 Kelvin. You are going to 1 atmosphere, 230 Kelvin. If it is reversible, you are going to 150 Kelvin. If it is irreversible, going to 230 Kelvin, right? अभी हमने 230 solve किया है. Reversible करते तो कितना आंसर आता? 150 Kelvin. Remember? So your endpoints are not same. If your endpoints was same, then my answer would have been same. If you go to 150 Kelvin, your answer would have been 0. Reversible case.
When you calculate
If you calculate the reversible case, you
got
that this formula. You give 150, then answer would have been same as in 0. Delta system should have been matched, but it was not same condition. Hence, we cannot say that our delta system will match. So the question is, what is not matching, what we can do? So answer is, you have to solve with any general process. अब general process क्या होता है? General processes, we have to use something which is not limited to just adiabatic condition, which is one place to other place via any reversible process. How can we calculate the value of what do you call ds? Okay, so write down ds is ये general formula, सबके लिए valid. Okay, कोई specific चीज के लिए नहीं, सभी के लिए valid है. Write down ds is, and please note down, and please write down this part also. DS system is not equal to dq reversible upon d. Write down end point of reversible reversal are not same. Write down what are the endpoints of reversible, what are the endpoints of reversible. Note कर लो सारी चीजें please. ठीक है, फटाफट नोट कर लो. देन एक ब्रेक ले लो, फिर इसको उसके ब्रेक के बाद ही करते हैं आराम से. फर्स्ट इसको कंप्लीट कर लो. यहाँ तक सभी लोग नोट करो. देन टेक अ ब्रेक, देन विल स्टार्ट फ्रॉम हियर. यहाँ तक कर लो. ओके.
So it's actually the same formula, just written differently.
It's the same formula, but now this time I can't use dq 0. I can't say du 0.
Like PQ is DU plus PD.
Correct, correct. And then we will try to integrate this as a general form.
Sure, how do we get 150?
With that T power gamma, P power 1 minus gamma constant. That is reversible applicable, right?
We
So
didn't
reverse-
find that though, right?
Yeah, we remember, we can find out and check, but those numbers will not match. That is 150, this is 230. So now you know already that in isothermal case, endpoints meet, endpoints match. But in this case, endpoints will not match. So your answer cannot be applied directly. Clear? Break ले लीजिए 10 मिनट का, then start. You just keep the video and audio off.
So why are you unmuted if there's no one there?
Record the recording.
They can watch recording. Okay. So write down ds is dq upon t. And dq is du plus pt. अब dq du plus pdv क्यों होता है? Because dq plus dw is du and dw is minus pdv. Correct? सोच कर देखो. तो du is dq plus dw, dw is minus pdv. तो minus pdv आपको उधर चला जाएगा. That will become du plus pdv. Upon t कर दोगे आप. ठीक है? So du is ncv dt plus p is nRT by v dv upon t. हो गया? So ds becomes ncv dt plus nRT dv upon v upon t. Now, in this whole discussion, have I used anything specific? कुछ भी specific use किया मैंने अभी तक? सारा generally, it's all general discussion. अच्छा जी. इसको integrate करके देखो value क्या आएगी? What will be the numbers? Integrate ds.
So which one? This.
Yeah. Yeah, this integrated ds will be integration of this, integration of this. So what will be the value coming up?
So it will become t2 minus t1 and b2 minus.
NCV dt upon t
And it should be
and then nRT
And then you get
dt cancel nR dv upon v. Two integration.
and then t2 by t1
Uh,
minus. And
Second term will be NR ln v2 by v1.
yes, nR ln v2 by v1. So integration become NCV ln v2 by v1 plus nR ln v2 by v1. अब एक और चीज बताओ, यहाँ तक कुछ भी मैंने स्पेसिफिक किसी की बात की है? इट्स अ जनरल थिंग. एक फर्स्ट लॉ यूज किया. फर्स्ट लॉ मतलब dq d plus dv is फर्स्ट लॉ. थर्मोडायनामिक्स यूज किया, वैल्यूज रख दी, इंटीग्रेट कर दिया. देयर इज नथिंग रॉन्ग.
the first law, delta u equals
Yeah.
u plus w.
Yeah, dq dv. Okay. Now any difficulty in this? So integration will come like this. We solve the whole thing. Just see, check your results. यहाँ तक पहुंच जाओ पहले सभी लोग. ठीक है. अच्छा जी. CD का वैल्यू कितना है? 3R. Why CD is 3R? R upon gamma minus 1. Gamma is 4 by 3. 4 by 3 minus 1 is 1 by 3. 1 by 3 का 3 ऊपर जम करके जाएगा 3R बन जाएगा. लिख के देख. CV is R upon gamma minus 1 is right. CV is R upon gamma minus 1. So एक बार आप सॉल्व करेंगे तो CV का वैल्यू 3R आता है कि नहीं? चेक. Gamma is 4 by 3. 4 by 3 minus 1 is 1 by 3. 3R हो जाएगा हमारी. अच्छा जी, यहाँ तो समझ में आ गया. अब मेरे को एक चीज बताइए. Delta S which we have got is applicable for all general cases. If the case is isothermal, what will happen? T1 and T2 will be
what? See?
T1 upon T2 is 1
Why?
or T1 T2 is same. So what is ln of T1 T2 upon T1?
0.
So what is the first term becoming here?
0.
0.
So what is the formula coming up?
NR ln v2 by v1.
यही तो यूज किया था isothermal में. Check your formula.
Yeah.
Which you have used.
Yeah.
NR ln V2 by V1. If the same thing is isochoric, isochoric means second one becomes
Second
0.
zero.
What is the formula?
NCV ln v2.
Note कर लीजिए, लिख लीजिए. In case of isothermal, T2 will be equal to T1. First term becomes 0. Formula becomes delta S. Isothermal is NR ln V2 by V1.
Volume 0.
Yeah, volume is not changing. Volume is not changing. Temperature is not changing basically. T1, T2 are same. So volume is not changing. It's isochoric. If volume is not changing, it's isochoric. V2 by V1 ln will be 0. So the second term becomes 0. Answer becomes NCV ln T2 by T1. ये सब किसकी वैल्यूज है? डेल्टा एस आइसोथर्मल, डेल्टा एस आइसोकोरिक. क्लियर? द सिस्टम ऑफ द सिस्टम ऑफ द सिस्टम. समझ में आया? पूरा कॉन्सेप्चुअली क्लियर हो रहा है? एंड दिस इज वेरी वेरी इंटरेस्टिंग एक्चुअली बिकॉज मेनी क्वेश्चंस विल कम फ्रॉम दिस एरिया इन एग्जाम आल्सो. So now you know isothermal treatment, now you know adiabatic treatment, now you know isochoric treatment. Coming to the current question. Current question was, we are going from 16 atmosphere 300 Kelvin to 1 atmosphere 150 Kelvin. That was irreversible. Sorry, that was reversible. 16 atmosphere 300 Kelvin to 1 atmosphere 220 Kelvin. That was irreversible. So we were solving irreversible case. And for irreversible case, we are supposed to solve delta S system. So which formula will be applied? This formula. In this formula, what is our T2 and what is our T1? Can we say 230 and 300? Check कर लीजिए. 230 and 300 values note करो. Values put करो वहाँ पे. Just please pass that charger from laptop. Yeah, thank you. So you can put values. It becomes 3 NR ln 230 by 300. देखो 230 क्यों लिखा मैंने? Because T2 is 230. And what is T1? Check this part first. T1 was 300. Correct batter formula? Is that okay? Second side, NR ln V2 by V1. Now, how will you solve V2 upon V1? P1 V1 upon T2. T1 is P2 V2 upon T2. Right? P1 V1 upon T1 is P2 V2 upon T2. Why? P1 V1 upon R T1 is N. P2 V2 upon R T2 is N. Moles are not changing, moles are same. So since your moles are same, then you can use this formula. Now V2 upon V1 comes out how much? P1 upon P2 into T2 by T1. अब मेरे को बताओ सबकी वैल्यू पता है. P1 कितना मेरा 16, P2 is 1, T2 is how much? 230, T1 is how much? 300. Please note down all the values. 16 से 1 पे गए, 300 से 230 पे गए. तो values मेरे को सारी पता है. Can I keep this value in terms of V2 by V1 here? Check please. Will that be your answer for delta system? Is it a general statement? Are we going from one random position to other random position, which is not adiabatic reversible case? Hence, delta system cannot be called zero. Are you okay? ये पूरा क्वेश्चन को समझ में एक बार हैंड रेज कर दो समझ में आया. So कोई डाउट तो पूछ लो.
Sir, how do you calculate error?
That's the next step. First, you understand this or not? You will complete करो. ये पूरा सही नहीं बेटा. This is P2 by V1 here. It is formula is V2 by V1. So you have to write this CCC.
Oh, that temperature.
That will also come into multiplication. No? 16 into 230 by 300 into that. कर लेंगे. कोई प्रॉब्लम नहीं आता. How to solve this? It's again a difficulty. Plus why? Okay. Fine. Okay. एक बार वापस से control tab, command tab.
Command help.
Yeah, and go to the Zoom part. Yeah, second one. Back to the meeting. Up. No, left. Below. Orange one.
Yeah, this
Back to the
one.
meeting.
Yeah.
Correct. Click. कुछ नहीं हो रहा है.
This is fine. No, this is the quizzer.
This is what I asked him. एक बार Zoom पे क्लिक करना होगा.
It's on the below that. There's a meeting end.
Just show.
I know, yeah, it's still there.
Well done.
Yeah, please keep that. Thank you. Is it clear? So delta system is this. Delta surrounding is how much? Minus Q irreversible upon T. That is the standard result. Now remember how much heat you are exchanging with surrounding in adiabatic. No heat exchange from surrounding. So right, Heat exchange from surrounding is 0. No exchange of heat from surrounding. Hence, my Q irreversible value is 0. So what is delta surrounding?
So why is no text?
Because in adiabatic process, what is the value of Q?
0.
What is that Q? Heat supply. It's 0. So exchange from surrounding is how much? Nothing.
0.
Okay, so I'm using direct formula that minus Q irreversible quantity is 0. System is this, surrounding is this, universe will be how much? System plus surrounding. Without even solving the first information, can you say the first information cannot be negative? ये तो बोल सकते ना अपन कि negative नहीं है first information. First information has to be positive. Why? Because delta zeros can never be negative. And by chance you get negative, that means you're doing something wrong. You get the point? So you add both the numbers. Your values will look like this. If you simplify, your values will come this. कर लीजिए एक बार अपने आप को complete करा.
How do you solve that ln part?
Yeah, I'm just keeping it at ln 23/30. Then we give the value. Don't worry.
Oh, okay. That
Okay. And ln 16, I'm writing ln 2 power 4. Always this is becoming 4 ln 2. Just see the calculation.
okay.
So I'm just trying to simplify this whole thing.
Oh,
Okay. Simplify कर लो, लिख लो value. Any problem with this? Delta universe is clear. Delta system is clear. Delta surrounding is also clear. Okay. Now, come to the next part. Third part. Free expansion. Right now. Free expansion. When definitions are no free expansion, then you can do it yourself. Free expansion is when you expand against zero external pressure. When you expand gas against zero external pressure, that means P external is 0. So what is the work done value for this? 0. What is the work done value for this? 0. Hello? 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 There. एक बार आप वापस कोशिश करो. मेरे को दे दो. Yeah. मुझे वेट कर रहा. Okay. Try करो. P external is 0.
The work is 0, then minus Q is 0.
Exactly.
Then
The whole thing is 0.
Then delta S of surrounding is 0.
delta surrounding is 0. Delta system, can you say 0? No.
That has to be positive.
So try. How much is the value?
But then
Can you comment
here,
about du? थोड़ा सोचो कर पाओगे. कुछ भी नई information नहीं. Whatever you know based on that you can
Then
solve.
U is also 0.
then
So what is the answer for delta system surrounding and think deeply, you'll get the answer. थोड़ा सा सोच लो.
but then delta surrounding also will be 0 because
Yeah,
there's
that's
no
right.
heat exchange. But then both of them can't be 0 because it's
Because it's irreversible. Correct. So delta system is what?
that
So do we have the end conditions?
Same. Yeah.
We have end conditions. What are the end conditions? T1, T2 are same or different?
different. But
You said delta is 0. You said delta is 0.
Yeah.
So T1, T2 are same.
Yeah.
You said delta is 0. You said dw is 0. Delta, sorry, W
Yeah.
is 0.
Yeah.
You said Q is also 0.
Okay.
So अब सोचो कि आपका T1, T2 तो same हो गया. So what is our general formula?
So then it'll be NR.
Ah.
It's for the it'll become isothermal. So then we get
Yeah,
NR
NR
and then
V2
V2
by
by
V1.
So what is the answer?
V2 by wait, but that's also
V2 by V1 is V1 by V2.
So what is the answer?
16. Like minus
NR and then
that's
16.
16.
And what is
Which is
LN16?
4 ln2.
4R LN2.
4R.
Very good. So your answer for the last phase will become 4R LN2. Okay.
Okay.
So it will look like this. Good. Smart बच्चे आपको इधर गया नोट कर लीजिए 4R LN2 0 and 4R LN2 are your answers. Clear? Universe is 4R LN2, surrounding is 0, system is this. Expansion में clear हो गया? Any problems, any issues, any difficulty, you may ask.
Sir, delta U is 0. So why did you say T1 equals
Delta U is NCV delta D.
Yeah. Oh,
So
Delta D is 0, T1 is T2.
yeah. Okay.
समझे पूरा? So पहला term 0 हो गया, NCV LN2 by T1 में NCV LN2 by T1 0 हो गया. What is the remaining? 4R LN2. That's the answer. All right. So this is about adiabatic process. Okay. So other batch we have done this much only. Now we'll do something in terms of question practice.
So is it over the chapter?
No.
How much is that?
Plenty of. Thermochemistry is also there. Thermochemistry is also a portion, right? So thermodynamics and thermochemistry. So the last question you missed. Last question work done is 0. Q is 0.
The DU is 0.
So delta U is 0.
Delta
is 0.
0.
No,
Delta T is 0.
no, over here. So like if
It
delta
was
U
other
is 0,
fast.
Guys,
if delta U is 0, then no temperature change. So T1 by T2 is 1. So then and then 1, this entire thing will become 0. And then you'll only have this part left. And then since no temperature change, it'll be NR ln16. Only because this is 1, right?
correct.
T, right? That's 4R ln2.
अच्छा तो याद है. Good. 4R LN2 is the answer. चलो कुछ क्वेश्चन सॉल्व करते हैं. फिर प्रैक्टिस करते हैं एडियाबैटिक एंट्रोपीज इन सब के क्वेश्चंस पे.
Sir,
Hmm.
sir, how long will this chapter go for?
अब आपके एग्जाम के पहले खत्म हो जाएगा. एग्जाम कब है आपका? 16, 17.
17th.
First exam scan.
No.
Yeah.
Answer this question.
Yeah.
Physics is on 19.
Chemistry first.
Oh yeah, okay. Enthalpy.
Answer नहीं किया but you can try. Enthalpy of vaporization of liquid is given. Entropy of vaporization is given. Boiling point of the liquid is given. Delta H.
Is equal to U plus delta PV.
Okay. It's delta U plus delta BV. वैसे अभी इसको आपने किया नहीं तो इसको छोड़ दो. अभी थोड़ा इसको पढ़ाना है. Then you can try it. Wait.
Yeah, share.
Because half-heartedly it will lose point. Right? They're not done that concept. So इसको जबरदस्ती इम्पोज नहीं करना चाहता है. ठीक है समझ लिया आपको. Do it आराम से. This you can answer. JEE Advanced 2014 का क्वेश्चन. वाटर लिक्विड वाटर वेपर में जा रहा है. टेम्परेचर है 100 डिग्री सेल्सियस. प्रेशर है 1 एटमॉस्फेरिक प्रेशर. अब बताओ क्या होगा. 1 atmospheric pressure 100 degrees Celsius shows it is equilibrium, because water boiling point is 100 degrees Celsius only. So what's the answer? Delta system is more than 0, delta surrounding is more than 0, delta system is more than 0. It's the first. Why A?
system is
No, system will decrease. Yeah, B.
No, but
Because
when you go
system-
from liquid to gas,
Yeah, but you're
entropy increases,
supplying-
no?
You're
Yeah.
supplying
We
heat
wrote
from
that
the
on the
surroundings to the system. System will increase, surrounding will decrease.
Correct, but it's not reversible. So that means
So yeah,
universe won't be entropy of
Yeah.
universe won't be
Yeah.
zero.
it won't be zero, but it will be positive.
Yeah.
System can be higher than surrounding also, no? System can increase, surrounding can decrease.
So correct, but you're supplying heat. So some heat from the surroundings will go to the system.
Hmm.
Right. So that's why, and when you go from liquid to gas, entropy of system will increase.
Hmm.
And since it's irreversible, entropy of universe can't be zero.
Hmm.
So that's why if entropy of system is positive, entropy of surroundings can't be negative.
No, that is why I'm asking why.
So because if it's negative, or it can be,
It
then
cannot
we
Plus
keep-
two minus one scenario, no?
Yeah.
It can be plus two minus one
Okay.
scenario plus one. So थोड़ा सोचो दिमाग लगाओ डेल्टा सराउंडिंग की डेफिनेशन मैंने क्या दी थी माइनस क्यू अपॉन टी अप्लाई दैट minus q upon t. So what is the heat exchange with surrounding? You have taken heat or not? You have taken heat. So what is minus q?
So minus. That will be negative.
minus of minus.
Huh, so what is the final answer? Now sum up the final answer. Which one you want?
B.
B.
सभी लोग B पे आ रहे हैं? अक्षय, आदित्य, क्या बात है? Congratulations. JEE Advanced 2014 का क्वेश्चन आपने सॉल्व कर लिया.
So
एक ही
they
क्लास
give
में.
this short question.
This is actually question of advance. I'm not changing anything. It's actually a question of advance. See, that's what I'm saying. Exam is not difficult. If
It's the
concepts are how
ranking,
clear,
it's the
that makes it
ranking.
difficult already. No, not ranking even. How good you know the concepts. Because what you feel is very simple is very difficult for very like a good number of students. Because they don't know these things in the right way.
Delta S of system is minus q by t.
Delta surrounding is minus q by t. Delta system, ds system is dq upon t. For reversible case. Integration आके delta system निकाल सकते हैं.
For isothermal, it's
Hmm.
yes upon t.
Hmm.
Otherwise,